Visual approach for factoring trinomials. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. This video is specially meant for parents and teachers who want to teach middle school students skills which they can learn early on. Factor trinomials is normally high school subject, but let us see how can we teach our middle school students the same skills. In case you're following my playlist, it'd be very good. And I will take up about 11 examples in this particular video to explain this concept that will help you to explain it to your students and children. In case you want to learn from me directly, you can always send an email on globalmathinstitute@gmail.com. Let me also thank all our viewers and subscribers for supporting us. As fellow Canadians, you can actually send your contributions via email, right? So, email transfer, as you know, is a very safe way of donating. You can send an email to globalmathinstitute@gmail.com. We want to reach millions worldwide who cannot afford quality education. Your contributions help. Even small amounts of $10, $20 work. Every dollar counts. And if you want to regularly support us, please discuss the plan by sending the email to us, and then we'll follow that plan. We can actually help you in many ways. Great. So let's begin with our lesson today. Our focus is how do we factor trinomials. So we have an area model here. You see a box, and in the box we have written some numbers: x squared, 10x, x, and 10. Now this box relates to area of a rectangle, right? So let us find the sides of this rectangle by factoring. So simple factoring skills: group factoring, x squared and 10x. What is common to x squared and 10x? We'll write in this blue box, and that is x, correct? So the term which comes here is x. So we'll write this term in our table as x here. Does it make sense? So we're trying to correlate the box with the table on the right and understand how do we write it in the factored form, which basically is kind of like this, right? And we'll also see how do we write in standard form, right? So, which is ax squared plus bx plus c. So once you understand all this, then in the next video, we'll do the reverse, factoring from quadratic equation to the factored form, right? So let's continue with this. Now x squared and 10x, x is common, and x and 10, what is common between that? Well, between x and 10, we have only one common, correct? So that gives us one of the factors, which is x plus 1. So we'll write here the factor x plus 1, which you can say is one side of this rectangle. Okay. The other side, if you go column wise, we have x squared and x. We know that here x is common factor. So that becomes x here. And in the next one, 10x and x, we know 10 is common, so we can write 10 here. So the next factor which we have is x plus 10. Does make sense to you? So see, we have written an expression which is actually x plus 1 times x plus 10. And when you expand this, what you get is the area inside this rectangle. So let's combine all the terms. We have x squared, right? So let me rewrite all the terms in this particular area, which is x squared. And you see, you can combine 10x and x, which are the like terms, which is 11x plus the last term, which is 10. So when you expand x plus 1 times x plus 10, what you really get is x squared plus 11x plus 10. So think about it like a quadratic equation x squared plus 11x plus 10, which has been factored as x plus 1 times x plus 10. And these are the sides of a rectangle. I know it looks like a square, but it's actually a rectangle, special rectangle, correct? Where the sides are x plus 1 and x plus 10. So I hope the process is clear. So we are writing each equation in the factored form, right? And also in the standard form. To do it in the standard form, you notice that the coefficients of x can be combined, which you give the second term in your standard quadratic equation. Is it making sense to you? Perfect. Let's take another example just to expand in our learning. So we'll prefer to work with the rows first. So first row x squared and minus 3x, we know x is common. And the second row 4x and minus 12, 4 is common. So we have x here and 4 there, which gives us the first factor, which is x plus 4. Clear, right? Now, looking in the column x squared and 4x, we know x is common. Minus 3x and minus 12 gives us minus 3 common. So, we can write x and minus 3 are the terms which can be multiplied, and we get x minus 3 as the length of this rectangle. So, width times length is the area, and the area is combination of all little areas, which are 4, right? So x squared is one of them in the left hand corner. The other two can be combined, as you can see. So minus 3x plus 4x leaves us with x, right? So we have x here plus the product, which is minus 12. So we'll write minus 12 here. Perfect. Minus 12. So you see how we have written all this. Now start noticing one more thing, right? When we are writing product P times Q and we are writing sum here, it gives you an idea of how these terms are related. So you can see that the center term, which is minus 3x plus 4x, gave us x, right? So this is this x, correct? And the product gives us minus 12. So what is this product? This is minus 3 times 4, which gives us minus 12. You see that? So that gives you the product, and that is how we are looking into this particular form. How do we relate our factored form into a standard form? Getting the idea, right? Okay, we'll explore more. So here's another example. I would like you to now pause the video, answer these questions one by one. As I move forward, rows first, we have x common here and we have 5 common there, right? So which gives us x and 5 as the first factor, x plus 5. Makes sense? The next one, column wise, we have x here and we have minus 3. So we'll multiply by x minus 3 as the second factor, and we can write here x and minus 3 as the terms. Now when you multiply them, we just add the area and we see minus 3 plus 5 is plus 2. So that gives us plus 2x, and the last term being minus 15. Makes sense? See, we have written the whole expression as a quadratic equation in both factored form and in standard form, right? So that is the beauty of it. Now let's continue. I hope the process is absolutely clear to you. Feel free to write a comment, share your views, and in case you want to learn directly from me, send an email on Global Math Institute at gmail.com. You can also contribute for us to reach millions, right? As we have been discussing right from the very beginning, which is also very important. And I know Canadians make huge difference in this beautiful world. So let's get back to our question, and this time we are on question number 4. So I hope you've got the answer. Rows first. So x and we have minus 2. Simple. X and minus 2 gives us the first factor, x minus 2. Now columns. We have x and 3, right? So we get x plus 3 as the next factor, and let me complete the table also as we move along. And now we are going to add, so x squared, the very first term, 3 and minus 2 gives me plus 1x, which we write at x, and then minus 6. So we have again written this model into two different forms, and we are calling them as factored form and standard form, right? So this is the standard form, and that is the factor form, correct? Let's continue. Question number 5. Now, once again, same thing, but we are going to learn now how do we relate these two factor and standard forms. So, let's begin with the row, which is x common factor. Next row is again 1 as the common factor, going to columns. So, let me first write x and 1 as our first factor, correct? We have x and minus 15, right? So, x and minus 15 gives us the second factor, x minus 15. Now look here. When you see that, then we are calling P and Q. Relate P and Q now. P and Q is 1 and minus 15, correct? So what is P plus Q? What is P plus Q? P is 1 for us and Q is minus 15. So that is equal to minus 14. So that is the sum, right? P plus Q. You get the idea. And that is how we get our standard form x squared minus 14x, correct? Which is basically combination of these two. Now you are able to relate the factored and the standard form in a much better way. Now the last term, as you can see here, is basically the product of P and Q. So if I have product of P and Q, which is 1 times minus 15, I get this as equal to minus 15. So that comes as the last term, the constant term in our quadratic expression, which is a trinomial because we have three terms. Three terms means a trinomial. Makes sense, right? So that is how I think this visualization is almost complete. We are able to link each and every part of our quadratic equation, understand what makes it zero, right? The factors, P and Q values make it 0, which we learn later. And how do we split it into different ways? Perfect. And a rectangle really helps us to link all these things in a visual way, which we are going to do more and more in this exercise. 5 more to go with you. 6. So I hope you have understood all these strategies. In all these equations, x squared is with coefficient of 1. So it's very simple exercise. Now in this video, we have 11 questions to work with. We have already done 5. This is the last one which I am going to solve, and the next 4 are for you to solve. Is that okay? So question number 6, we can see, if you see the row, x is a common factor, the second row minus 1. So we get x and minus 1, x minus 1 as the first factor. The other one being x is a common factor and 20. So x plus 20 is the next one, correct? Let's fill this up, right? So we get the terms, which is x squared, the sum of the roots, which say 20x minus x is 19x, right? And when we multiply them, we get minus 20 as our answer. So I hope you have understood this strategy. Well, you can always send an email to me to learn more or even to contribute in our effort to reach millions, right? Here are the other questions for you to solve. Make a note of these, correct? You can always pause the video, answer these questions, right? So these are the other 5 questions for you now to practice. So I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.